This is day 23 of Unit 7. We started today with a ticket in the door, so you'll need to make that up if you missed class. And then we did this warm-up. So pause the video, try the warm-up, and then play to check your answers. So number 1 says to find the inverse of y equals 6 plus 2 to the x. So I can see that that's an exponential equation, which tells me then, because I know the inverse of exponentials are logarithms, that tells me that I'm going to have to put that into log form. So first I'm going to make that y equals. And I need it to be in exponential form before I can put it in log form. So I need to get that 6 over to the other side. So now that I have it in exponential form, now I can rewrite it in log form. So log base 2. So 2 to the x is equal to y minus 6. So log base 2 of y minus 6 equals x. So then rewriting or interchanging the x with the y. And lastly, making that f inverse of x is equal to log base 2 of x minus 6 is equal to f inverse of x. So that is our inverse equation. Number 2, this is a review from earlier in the unit. We're using y equals a times b to the x plus k, which is the asymptote. So y equals a times b to the x plus 6. So I'm substituting in 0, 9. I don't know why my pen stopped working there. And this is a 9. And my second equation is 12 equals a b to the first plus 6. So subtracting 6 gives me 3 equals a times b to the 0 is just 1. So that means that a is just 3. So then 12 equals 3 times b to the first. Oops. I don't know what that is. I don't know why there we go. So this is b. 3b plus 6. Subtract 6 from each side. 6 is equal to 3b, which means b I don't know why this pen's not working, is equal to 2. So my equation is 3 times 2 to the x plus 6 equals y. Okay, so today the notes came from problems in the packet. So on page 20, you can just date that page. That was our notes for today. So page 20, problem number 13. So we started by, these are solving logarithmic equations. Well, I need to, when I have 2 logarithms, I need to condense that into 1. So I'm going to use the quotient property, which says that's going to be 6 over x. And then I can see I have one logarithm, and I know that when the base is not written, that's base 10. So I can rewrite this in exponential form. And I can then solve for x. So I know multiply both sides by x. So I'm getting 10x is equal to 6, which means x is equal to 6/10 or 3/5. And that's my solution. Next, we're going to work on problem 15 on the same page. So once again, on the left here, I see 2 logarithms. I'm going to condense using the quotient property. So now I have a log equal to a log. So in order to solve that, well, first of all, the bases have to be equal, which they are. They're both base 10. So if the bases of the logarithms are equal and the logarithms themselves are equal, that means what I'm taking the log of has to be equal. So basically the log just kind of drops out, and I'm left with x squared over 4 equals 4. Those expressions have to be equal in order for the logarithms with the same base to be equal. So I can solve by cross multiplying, and x squared equals 16. Square root of both sides, I know the square root of x squared is the absolute value of x, and the square root of 16 is 4, so x is equal to plus or minus 4. Now, I mentioned in class that a couple things that cannot happen ever. You can never have log with a negative base. So that can never be negative. Also, what you're taking a log of cannot be a negative number. Okay, so that you can't have. No negative bases, no log of negative numbers. So depending on where the x is in the problem, that could cause a little bit of an issue. So what we need to do is we need to make sure that substituting in 4 or negative 4 into the original equation, that's not going to cause us to have log with a negative base or log of a negative number. So putting 4 in, 4 squared is 16, that's fine, log of a positive number. Putting negative 4 in, negative 4 squared is also 16. So that's not going to cause a problem, log of a positive number. Now, had this original equation been log of x instead of x squared, and I got negative 4, then putting negative 4 would be a problem. Log of a negative number can't do that. So then in which case I would have to cross off negative 4 and say that's not an answer. I don't need to do that though, because again, when I square negative 4 or positive 4, I get positive 16. So I have log of a positive number, and that's fine. Okay, but you do need to check to make sure that x is not in the base spot, or that where x is, and whatever depending on what the value of x is, I don't have log of a negative number. Okay, we did one more. We did problem number 10 on page 20. So this one, again, looks similar. I do have a logarithm, but I have these extra numbers. I have this 8 that's being added on, and I have this negative 8 that's being multiplied. I need to get rid of those before I can do any of the work that we've been doing on the last several problems. So I need to get rid of that 8, the same way I have for years. I need to subtract it. So when I do that, I'm left with negative 24 here on the right. I have negative 8 log of 7n plus 10. So I still need to get rid of that negative 8 before I can apply any of my properties. Now, a lot of times students will say, well, can I use the power property? Well, you could, but do you really want to take the quantity 7n plus 10 to the negative 8 power? I know I don't. So the easier approach would be to get rid of that negative 8 by dividing. So that leaves me with log of, now this 7n plus 10 does not change. We're taking the log of that. It's not like I'm dividing that number itself by negative 8. So just the negative 8 gets divided by negative 8. And then over here 3. So now from this point on, now it's an algebra 2 problem. Now it's a log problem. The first couple steps, again, those were just basic pre-algebra. So base 10, 10 cubed equals 7n plus 10. So 1,000 equals 7n plus 10, which means, whoops, missing a 0, which means 990 equals 7n, which means n equals whatever 990 divided by 7 is. I'm just going to leave that as an improper fraction. Okay, and putting that in is not going to cause any issues, and don't have log of a negative or log with a negative base, so I'm finished. Okay, your assignment is to do the rest of, well, not the rest of, but problems 11 through 30 on page 20. And you do have a quiz coming up later this week on Thursday.